Okay, good morning. We are going to start, I'm going to do two rate problems. So this is a rate in and a rate out problem. And you may encounter one of these on the AP test. Okay, so I like this one because it combines a couple of different concepts. Combines a regular function, but then also a piecewise function. You may also get a regular function in a table or something, so they may throw something different at you, but you're going to be able to handle it. All right, so here we got Janet. There's no snow on Janet's driveway when the snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at this rate. All right, where T is measured in hours since midnight. Janet starts removing snow at 6 a.m. She's up early. So at T equals 6, she starts shoveling. And the rate she shovels is modeled by this piecewise function. She shovels, looks like, at a constant rate, right? And then she slows down at 7. So she goes at it from 6 to 7, and then she slows down from 7 to 9. She's shoveling a lot. Okay. So the first question, and as you've noticed, the first question tends to be a little bit easier than the rest. So we can definitely do A. So let's focus on A right now. I like it. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? Okay, and they're giving us a rate. So if they give us a rate, how do we find the amount? I know you said it. You said integrate, right? Or antiderive. So we are going to antiderive from 0, midnight. We're going to say that that's 0. And we can write midnight equals T equals 0, right? Or midnight like that. Or T equals 0. T equals 0. I said it right. I didn't write it right. And then at 6 a.m., T equals 6. And we're going to antiderive the rate of snow falling. Okay? And the easy thing about this problem is it's a calculator problem, so we don't have to actually antiderive that. We can just use our calculator. So I'm going to clear out what I have, and I'm going to put in my function, 7x e, second function e to the cosine x. So make sure your calculator's in radians when there's a trig function. Okay, and then I'm going to quit out of here. And then I'm just going to use my y1. So math 9 is the integral in a calculator, 0 to 6. And then I just put that function in, and it is y1. So alpha f4 gets me to that menu. And dx. Uh-oh. What did I do wrong? Oh, shoot. Oh, I put it in y2. Okay, well, that'd do it, wouldn't it? Okay, so we can just go up. Oh, Lord. Yeah, I'm not very good at this, am I? All right, there we go, y2. Aha, that looks better. Okay, so we got 142.274 6, and we can just truncate it up 4. And we do have units on this problem. It is cubic feet per hour. We antiderive, so we get cubic feet of snow. Okay, so part B. Find the rate of change of volume of snow on the driveway at 8 a.m. So the volume of snow is the volume, the rate coming in, right? And the rate going out. That's the rate of change of volume. So I'm going to say, let's say V of T, we can just say is volume of snow. We can define it. So the rate of change of volume would be V prime of T equals rate of change of volume. Okay, so of snow. volume of snow on driveway. Okay, so V prime of t is equal to, and then we've studied this a little bit. We've done a little bit like this. Rate in minus rate out, right? And so F of t is the rate in, and her shoveling, Joanna's shoveling here, or Janet's shoveling, sorry, is G of t. Okay? So now we want to find the rate of change in volume at a specific time at 8 a.m. So that's at t equals 8. So I'm going to say V prime of 8 is equal to F of 8 minus G of 8. Can you guys see that? Yep. Okay, so V prime of 8 is equal to F of 8, which is 7 times 8 e cosine of 8 minus, now G of 8 is 108. That's a constant. Okay, and we can figure this out with our calculator. Remember, we plugged it in. I thought I was plugging it into Y1, but I didn't. I plugged it into Y2. And now I can just go to the table, and I want 8. So that gives me 48.417. 417 minus 108. And let's see what that would be. 48.417 minus 108 is equal to negative 59. Negative 59.583. So what does that mean? Cubic feet of snow. Per, this is a rate, so that's per hour. Okay, so that means that she's shoveling a lot faster than it's snowing, right? So negative 59.58, that's the difference. Okay, we keep going. Keep going. Got that? We can box our answers here. It's probably good policy, right? Help the grader. Okay, part C. Let's see. Let H of t represent the total amount of snow in cubic feet that Janet has removed from the driveway. Okay. At time t hours after midnight. Express H as a piecewise defined function with the domain 0 to 9. Okay, so this is a little bit more involved here. So we've got to anti-derive, right, the rate here. So if we anti-derive 0, we still get 0, right? She's not shoveling, so she just still doesn't have any amount of snow that she's removed. So from 0 to 6, I'm going to say that's still 0. So we're going to say H of t is equal to 0 4 to 6. Okay? Because that represents the total amount of snow that she's removed, and she hasn't removed any before she wakes up, right? Okay, now it's just a constant rate. So a constant rate from 6 to 7, well, if we anti-derive a constant, we just get 125 times t. Yeah, you got it. So 125 times t for 6 to 7. Now it gets a little bit more complex, okay? Now we've changed the rate, but we have an initial amount at 7. It's 7 times, no, it's 1 hour, not 7. So we've got to, wait a second. I'm thinking here. Yeah, we haven't been shoveling for 6 hours, so we can't just put in 6 here. It's t minus 6, isn't it? Right? Aha, I'm thinking now. So for 1 hour, she's removed a total of 125 cubic feet. Aha, I have to think a little bit too. Okay, so now at 7, she started out with 125. She's already removed that. Plus now the 108, right? So now she's removing at a different rate 108. And that doesn't start till t equals 7. So then that's going to be t minus 7 for 7 to 9. So another way to look at this, which might be helpful, is if we graphed g of t. So we're going to graph t of t. It's 0, right, till we get to 6. And then 6 to 7, it's up here at 125. And then it jumps down from 7 to 9. Okay, at 108. So what we're doing is we're finding this area under the curve. And so you can see now why I had to subtract 6, right? Because this distance is not 7. It's 7, it's minus this distance here. So it's the t value somewhere in here, right? We don't want to find this whole area. We just want to find this amount in here. Okay, so this is our t-axis. So that's t minus 6 times 125. And then we have to do the same thing here for this area. It's 108 times t minus 7. That gives us that. Okay, and now we're on to the last part, D. How many cubic feet of snow are on the driveway at 9 a.m.? So what we want to go, I'm going to go back, volume of snow on driveway to my B right here. This is what I want to find. I want to find V of 9, right? Well, we have V of t. Can we anti-derive from what we know to what we want to know? I think we can. I think we can do it. So that's what we want to find. Let's see. So if we anti-derive V prime of t, and we want to know V of 9, that'll be our first anti-derive V prime. We get V of 9 minus, and do we have an initial amount? I guess we do. Let's think about this. Yeah, let's do it. Let's start at 0. We know at time t equals 0, we have 0, right? So let's start at 0. V is 0. Okay, and we know we start at 0, right? We know there's no snow on the driveway at time t equals 0. So I think we're okay here. Now we just have to figure out how to anti-derive this. So V of t is equal to the rate in minus the rate out. So I'm going to break this up into f of t dt minus 0 to 9 d of t dt is equal to V of 9. Okay, this one is easy. I can put that into my calculator. So again, math 9, 0 to 9. Oh wait, did it stop snowing at any time? Accumulates at the rate where t is measured since midnight. Janet's, no, it never stopped snowing. So, okay, it's still snowing at 9 a.m. So, and then it was a Y2. Okay, so we got 367.3346. That's the amount of snow that fell onto the driveway from 0 to 9 a.m. or from midnight to 9 a.m. Okay, now we're going to subtract. Now we have to use our piecewise define functions. So from 0 to 6, it didn't do anything, right? We didn't shovel at all. Now from 0 to 7, we can find from 7 to 9. So we're going to say, okay, now she shoveled 125 from 6 to 7, and then at 9 a.m. we've shoveled that total amount. So that's our antiderivative of G of t is H of t, right? So we can just plug this all in. 2 times 108 plus 125. And we've got 367.3346 minus the 341. And we got, she's almost done, cubic feet of snow. And there we have it. Done. So we had to anti-derive, which we already did in part C for our G of t. And then we anti-derived via the calculator for the rate in minus out. All right. Good job, you guys. Thank you.